Welcome you all. Myself Nagarajan, Assistant Professor in EC Department, Rohini College of Engineering and Technology. In this course, we will see about the embedded system and IoT subject for biomedical engineers. The topic is a sensor and sensor node in IoT. So let us see the what is it sensor. So sensors are crucial components in IoT system responsible for capturing physical or environmental data and converting it into a electrical signals. So sensor nodes are is nothing but it is a refer to the combination of a sensor or microcontroller and communication modules and a power source forming a self-contained IoT devices that can sense, process and communicate the data. Now let us see the types of a sensor in IoT. First one is a environmental sensor. So in environmental sensor, the lot of temperature sensors are there, and humidity sensors are there, pressure sensors are there, and gas sensors are there. So in temperature sensor, it will be measure ambient temperature using devices like thermistors, RTD, and thermocouples. Humidity sensor, it detects moisture levels in the air, commonly using capacitive, resistive or thermal conductivity sensor. And pressure sensor means it is measure the atmospheric or fluid pressure using piezoelectric or capacity sensing element. And gas sensor means detect the presence of a gases like carbon dioxide, methane or oxygen using a chemical infrared sensor. And next, motion and position sensor. Accelerometers, so measures acceleration forces, detecting movement or orientation changes. Magnetometers, it detect magnetic field, often used for compass functioning or metal detection. Proximity sensor, detect the presence or absence of object within a certain range using ultrasonic, infrared or capacity technologies. Next sensor is a optical sensor. So photodiodes. So in optical sensor we are using photodiode. It is a convert a light into a electrical current used for detecting light intensity. And next cameras. So capture image or video providing visual data for processing. And next LIDER, that is the light detection and ranging sensor measure distance using laser light used in autonomous vehicles for mapping. Next biomedical sensor, so heart rate monitors, it will be measure pulse rate using. Next glucose monitors, so glucose monitor detect blood glucose levels using electrochemical sensing. Next electrocardiogram sensor, it will be measure the electrical activity of the heart used for cardiac monitoring. Next chemical sensor, so in chemical sensor, that is a pH sensor is available. So it will be measure acidity of a solution using glass electrode. And biosensor, it will be detect specific biological molecules using bioreproductives like enzymes or antibodies. Next sensor node. So sensor node means it's a combination of a sensor, microcontroller, communication module and power source is a sensor node. So components of a sensor node. So what are the components present in the sensor node means first one is a sensor. So sensor, it is a primary components that measure typical quantities and convert them into electrical signals. Then microcontroller. So microcontroller, a compact integrated circuit that process data from the sensor and control communication and power management. Then communication module, it will be enable the sensor node to transmit data to a gateway. So common modules included Wi-Fi, Zigbee, Bluetooth and LoRa. And power sources provides a energy to the sensor node. Typically batteries or energy harvesting systems are there. Next, in a sensor node, let us see the types of a sensor node. In a sensor node, we have a two types of a sensor node is available. One is a single sensor node, and another one is a multi-sensor node. So, single sensor node means it contain one type of a sensor for a specific application. Like a example, it's a temperature monitoring. So, multi-sensor node means it combine multiple sensor in one node to capture various type of data. For example, weather station node with the temperature, humidity and pressure sensors are combined together. So it is a multi-sensor node. Next, sensor node architecture. So in the sensor node architecture, we have here separate units are there. One is a sensing unit, next to processing unit, and next to communication unit, and then finally that is a power management unit. In the sensing unit, it will include the sensor and anti-lock, that is the analog to digital converter that digitalize the sensor output. Then processing unit. In the processing unit, the microcontroller that process the sensor data and manage the node operation. In a communication unit, it will be handled data transmission using wireless communication protocol. Then power management unit, it will be ensure efficient use of power, often incorporating energy harvesting technique to extend battery life. Next, we see about the challenges in sensor node design. So first one is a power consumption. What are the challenges we facing in a sensor node design? It is a power consumption. So power consumption, we need to minimize in the power usage in critical for prolonging the life of battery powered sensor node, especially in remote or hard to access the area. So next one is a data accuracy and reliability. So data accuracy, ensuring that sensor provide accurate and consistent data is vital for the IoT system overall performance. And next, size and form factor. Sensor node must be compact and particularly in wearable or embedded applications. Next one is a communication range and reliability. So balancing communication range with the power consumption and ensuring reliable data transmission in various environments. So embedded target boards are developed platform used to build and test IoT system. So I hope that all of you understood about the sensor and sensor node. So sensor means it will be collect the capturing physical or environment data and it is converted into a electrical signal. Sensor node means it is a collection of a combination of a sensor, microcontroller, communication module and power source. Thank you.